Hi everyone, I'm Jiang Taoxie from Dalian University of Technology. Here we will present our work about the deep learning distance covariance for field shot classification. Next, we will introduce this work from these aspects. The field shot image classification focuses on how to train a model when only few images in each class. In the experiments, this task can be defined as NVK shot learning. There are examples, 3-way 2-shot. We can see the support site has 3 classes and 2 images in each class. One of the approaches for field shot learning is matrix-based method. Pipe-level previous matrix-based art is shown in this figure. They use similarity function to compute the distance between support and query. From the statistical view, the similarity between features can be seen as the distance of feature statistics. Like mean vector mu used in PertNet, covariance matrix sigma used in CVNet, and the ADM uses Gaussian. However, they are all marginal distribution with limited compatibility. DeepEMD suffers heavy computational cost, though it exploits joint distribution and achieves competitive performance. This is overview comparison. Our DeepBDC uses joint characteristic function as a probability model, which has joint compatibility. We implement the DeepBDC as a highly modular and efficient layer, achieve the new state vector performance. So, what's the Brownian distance covariance? Here is the formula of a BDC metric. It's the Euclidean distance between joint characteristic function and product of the marginals. Phi xy is the joint characteristic function. Phi x and phi y are marginals. The properties listed here is character dependency and linear correlation. Meanwhile, it is invariant to individual translation and the orthogonal transformation of x and y. Here is BDC in discrete condition. The feature map of convolutional features can be seen as a random vector. The set of x and y represent the support and query features. Then we can compute the BDC matrix by these formulas. Then we implement these formulas as a polling layer. We use the BDC module separately compute BDC matrix for support and query image, then apply inner product to obtain similarity. Here is the detailed implementation. We can take a feature map as a random vector from spatial view as introduced just now. Meanwhile, we implement channel polling while taking channel vector as a random observation. Next, we will introduce how our BDC module apply in 2 field shot learning paradigms. The first is MATDeepBDC. It builds on PertNet. We replace the original mean vector by our BDC matrix and final image repetition. The second is simple transfer learning framework. The STL-DeepBDC is based on Gooding band. We use BDC matrix of input image to train a classifier for novel task. Now we move on the experimental part. Here is a comparison on mini-ImageNet and teraImageNet. From the table, we can see our STL-DeepBDC achieves the best accuracy on all settings. The rectangular is the previous state vector results. Our MATDeepBDC also achieves very competitive performance. On fine-grained task COB200, our DeepBDC outperforms FRM about 1% on both 1-shot and 5-shot setting. On the cross-domain task, we compare 5-shot performance with counterparts. From the table, we can see both of our instantiations outperform other methods. Next is the ablation study. Here is a comparison of spatial polling and channel polling. We can see the spatial polling is better, and we use it across the experiments. Is how to compute prototype for MATDeepBDC. The first is average the BDC matrices. Second is average the features. The last one is the feature concatenation. The best one is the first scheme. We evaluated the work clock time of meta training and meta testing. From the table, we see the DeepEMD has a huge time consuming, while our DeepBDC is very fast, only slightly slower than the PertNet and ConvNet. We introduced the Brownian distance covariance into deep learning for the first time. Meanwhile, we formulated the DeepBDC as a highly modular and efficient layer for featured learning. Experiments show the DeepBDC established new state vector results on 6 field shot benchmarks. DeepBDC is a fundamental, powerful method for modeling statistical dependency and similarity distance in deep learning. It has potentially wide application whenever you need a distance similarity in deep learning. Thank you.